Welcome to The Explainer. Today, we are diving deep into the world of IT. If you've got a tech interview coming up, or maybe you just want to really get the fundamentals down, you are in the right place. We're going to break down all the core concepts from the physical stuff you can actually hold to the cloud that runs pretty much everything. So, here's the game plan. We're going to start with the absolute basics, what a computer even is. Then we'll crack it open, look at the hardware and software. After that, we'll see how they all talk to each other to create the internet, and of course, how we keep them safe. And to finish things off, we'll touch on the magic behind programming and peek into the future with things like AI and the cloud. All right, let's kick things off with Section 1, Computer Fundamentals. Look, before we can talk about all the cool stuff like coding or the cloud, we've got to start at square one, with the most basic question you can ask. And that is, what is a computer, really? Seriously, everything else we're going to talk about today builds on this one simple idea.
Okay, so at its core, a computer is just an electronic data processing device. That sounds kind of technical, but all it really means is that its job is to take in raw stuff, the input, do something with it, and then spit out something useful, the output. The calculator example is perfect. You give it 2 plus 2, that's raw data, it does its thing, and out comes 4. That's useful information. And this right here is the key difference. Data is just raw facts. Imagine a huge, messy list of every single sale you made today. It's just a jumble of numbers, right? Not very useful. But then the computer processes it and suddenly you have information, like a nice, clean chart showing you that you sell the most stuff between 12 and 1 p.m. Now that is something you can actually use. Okay, moving on to Section 2, hardware, software, and storage. So we know a computer processes data, but how? Well, it needs two key things, the physical parts, the hardware, and the set of instructions that tells that hardware what to do. That's the software. It's a really simple way to think about it. The hardware is all the physical stuff you can actually touch, the keyboard, the mouse, the screen. The software, on the other hand, is the brain. It's the programs and code that make the hardware do useful things. And you absolutely need both. Hardware without software is just a fancy doorstop, and software without hardware is, well, it's just code on a screen.
And right in the middle of all that is the operating system, or OS. This is, without a doubt, the most important piece of software on your device. Think of it like the conductor of an orchestra. It's the OS's job to make sure all the different parts, the hardware and all the other software, are working together in harmony and not crashing into each other. I guarantee you use one of these every single day. You've got Windows on most laptops and desktops, Android on the majority of smartphones, and then there's Linux, which is kind of the unsung hero. It powers a huge chunk of the internet servers. They all do the same basic job, managing the computer, but they're built for totally different environments.
I love this analogy because it makes it so easy to understand. Think of RAM as your desk. It's your temporary workspace where you put all the stuff you're working on right now. But as soon as you turn the computer off, poof, the desk gets wiped clean. ROM, on the other hand, is like the permanent instruction manual that's glued to the wall. It holds the super basic startup instructions, the stuff the computer needs just to turn on. It never changes. Okay, so we've got a handle on how one computer works. But let's be honest, the real magic happens when they start talking to each other. So now, let's get into networking and how we connect these machines to share info, whether it's across a room or across the planet.
Really, this just comes down to size. You've got a LAN, a local area network. That's small scale. Think the Wi-Fi network in your house or your office. Then you have a WAN, a wide area network, which is for connecting things over a huge area. And what's the biggest WAN of them all? Yep, the internet.
This is a great way to think about it. The MAC address is like your device's fingerprint or a serial number. It's physically burned into the hardware, it's permanent, and it's unique to that one device. The IP address, though, that's more like your current mailing address. It's assigned to you when you connect to a network, and if you take your laptop to a coffee shop, you'll get a new one. It's temporary and logical. DNS is basically the internet's phone book. That's it. You and I remember website names like google.com, but computers, they only understand numbers, those long IP addresses. DNS is the incredible system that does that translation for us, instantly connecting the name we type to the number the computer needs.
So we've got billions of devices all connected and talking to each other, which is amazing, but it also opens up a ton of risk. So for our next section, we absolutely have to talk about cybersecurity, the basics of how we protect ourselves and our data in this giant digital world. Okay, so in the security world, everything comes down to these three letters, CIA. It's called the CIA triad. Let's use your bank account as an example. Confidentiality means keeping it secret. Only you should see your balance. Integrity means the data can't be tampered with. A hacker can't change a $10 payment to a $1,000 one. And availability means you can actually get to your money when you need it. If you're missing even one of these, you're not secure.
And here are some of the bad guys you'll run into. First, you've got malware. That's just a catch-all term for any nasty software designed to mess up your computer. Then there's phishing. This is pure trickery. It's that fake email pretending to be your bank, trying to fool you into giving up your password. And then there's the really scary one, ransomware. This stuff is digital kidnapping. It locks up all your files and demands you pay a ransom to get them back.
So, how do we fight back? One of the single most powerful tools we have is MFA, or multi-factor authentication. Seriously, if you're not using this everywhere, start now. It's like having two locks on your door. A password alone is just one lock. MFA adds a second one, usually a code sent to your phone. It makes a hacker's job so much harder. All right, so we get hardware and software, but how does software actually happen? How do we tell the computer what to do? It's time to pull back the curtain a little bit and look at the basic logic of programming.
First concept you gotta know is an algorithm. Don't let the word scare you. An algorithm is just a recipe. That's it. It's a list of step-by-step instructions to get something done. Just like baking a cake, you have to follow the steps in the right order, and if you do, you get a predictable result. It's the exact same idea for computers.
And really, almost all programming boils down to two basic ideas: loops and conditions. A loop is for doing something over and over again. Think, check every email in my inbox for spam. A condition is for making a decision. It's based on if this, then that logic. Like, if the password is correct, then let the user log in. That's pretty much it. All the complex apps you use are just built out of these simple blocks. Okay, for our final section, let's talk about the really exciting stuff. This is the future. We're going to look at the cutting-edge tech that's built on top of everything we've just learned. So you hear these buzzwords all the time. Let's break them down real quick. Cloud computing? That's just using someone else's computer over the internet. Anytime you use Google Docs or watch Netflix, you're using the cloud. AI, or artificial intelligence, is all about making machines smart enough to learn and make decisions. Think about your email's spam filter. And the Internet of Things, or IoT, that's about connecting everyday objects to the internet, like your smartwatch or a smart thermostat. Wow, okay, so we've covered a ton of ground, from the most basic definition of a computer all the way up to AI. Which leads us to one last really important question. Why does any of this matter for your career? Why are things like IT certifications so important? And here it is, plain and simple. Getting certified in this stuff improves your skills and, you guessed it, seriously increases your job chances. Look, every single thing we talked about today is a building block of our modern world. Getting certified isn't about passing a test. It's about proving you speak the language of technology. And being fluent in that language, that is what's going to open up so many doors for you.